Welcome to the Calsoft podcast series. This is your host Mark Rodriguez. With me today I have Misbah Khan, a senior principal engineer here with us, Calsoft, and he's going to be talking about the NSX hardware VTEP integration. Hi Misbah, it's good to have you here.
Hello Mark, how are you doing?
I'm very well, thank you. Before we get into the topic, Misbah, I want to introduce you to our listeners.
Sure.
So like I mentioned earlier, he's a senior principal engineer here with us at Calsoft, and he's worked on multiple projects that have primarily focused on the design and the development of software applications, along with providing strategic software solutions to multiple partners. Misbah actually specializes in the virtualization and the networking domain. So once again, it's great to have you on the show.
Yeah, thank you so much Mark, and thanks for the introduction.
So Misbah, can you tell our listeners what we're going to cover in today's podcast?
Yeah, sure. So today I'll be talking about this NSX hardware VTEP integration, its design and how it could be achieved. So basically VMware has recognized and understand to address the needs of its customers, especially when they are moving towards the virtualization infrastructures. So VMware NSX provides the hardware gateway capabilities between the physical and virtual networks.
What exactly do you mean by the hardware gateway?
Okay. So hardware gateway is, so you can think of it as a physical hardware, underlying hardware, and with this hardware VTEP integration you can actually enable the virtual entities and the physical entities to start communicating with each other.
Okay. So before I interrupted you, you were talking about how the VMware NSX provides hardware gateway capabilities between the physical and the virtual network. So you want to complete that?
Yeah. So you would be using this VXLAN technology for this hardware VTEP integration, where VXLAN is used as an overlay solution to extend your layer 2 segments. This layer 2 segments is basically nothing but layer 2 bridging, where, so as I said, where virtual entities and physical entities start communicating after VXLAN to VLAN translation.
Correct.
Or you can say binding. So yeah, so I'll explain it in more detail as we proceed.
So Misbah, you want to get into the details of how this works then?
Yeah, so let me go a step back and start from VMware. So as you know, VMware is the leader in software defined compute. They call it as virtualization, which is the first step toward the software defined data center, SDDC. This has been introduced by VMware more than a decade now, and this server virtualization has become a standard technology which is used by a majority of data centers worldwide now. Virtualization has enabled decoupling between the CPU and memory from the physical hardware, and each virtualized application and its operating system is encapsulated in an isolated software container. They call it as a virtual machine, and you can run many such virtual machines simultaneously on multiple physical servers. So that will enable, that will basically improve the overall productivity of your underlying hardware.
So this obviously has then resulted in better performance and high availability, right?
Exactly.
Okay.
And VMware has come up with this VMware NSX, which is the VMware's product only. But this VMware NSX has great software capabilities for networking and security layer. This VMware NSX is a virtualization platform for the networking services that provides the network virtualization the similar way VMware has come up with server virtualization earlier.
I remember the last time we had discussed, you were talking about how in NSX virtual networks can be provisioned within few seconds, right?
Yeah, in VMware NSX you can actually provision your virtual networks in a fraction of seconds, and you can even manage them independently without getting into the underlying hardware, similar to as you do VM in computing.
Correct.
So basically you can create your logical objects in NSX as per your networking needs. Just to mention few, like logical switches, logical routers, logical firewalls, load balancers and whatnot. But apart from all of this, one of the key aspects that VMware has recognized and understand is that they have addressed the other needs of the customers, especially when they are moving towards the virtualized and cloud architectures now. which I have already mentioned in the introduction.
Correct.
So VMware customers can take this advantage of integrating their technology with existing VMware ecosystem, which could provide them high-end performances and services.
So how does this make a difference in the data center then?
Okay, so I was supposed to move to data centers only.
Okay.
So in typical data centers, not every machine is virtualized. You have these bare metal servers, which are common physical devices in most real data centers worldwide, which are not virtualized. There are these physical workloads which run independently. You can say them as physical servers. They could be like database servers, storage arrays, firewalls. So considering this large-scale deployment, VXLAN is a great concept that provides virtual networks separate from existing physical infrastructure. Mark, with VXLAN you can have up to 16 million layer 2 segments as compared to only 4,000 with a VLAN.
It's a massive improvement.
Yeah, exactly. So with VXLAN, VXLAN is basically suitable for your large scale deployments where this 4,000 layer 2 segments won't suffice.
But that obviously means that VXLAN terminates at the physical hardware or the underlay, right?
Yeah. So that's the thing actually. I mean, with VXLAN that get terminated at the physical hardware or underlay, you can say.
Okay.
One of the common use case of VXLAN is that it provides gateway functionality between physical and logical networks. There are other use cases of VXLAN like integration with OpenStack, VM mobility across layer 3 segment and whatnot. But today I'll be focused on this use case only, where I'll explain hardware gateway capabilities of VXLAN between physical and virtual logical network, where this VXLAN is used as an overlay solution to extend your layer 2 segments basically. Yeah.
Okay. So Misbah, tell us how all of this integrates into the VMware ecosystem then.
Okay, so considering VMware ecosystem, you have these virtual machines running on ESX servers. These virtual machines are supposed to access physical bare metal servers, BMS, they call it as BMS, which are connected to underlying hardware infrastructure. Now on the NSX side, you are required to add your virtual machines to NSX Logical Switch. This logical switch is a logical entity. This logical switch should be bound to a particular VLAN, enabling communication to bare metal servers on either same or different subnet. Apart from this, NSX provides the flexibility to add physical switches as hardware gateways to it. So you had this question, right? What are these hardware gateways? They're nothing but the physical switches.
Correct.
The VXLAN hardware gateway is a VTEP, which performs VXLAN encapsulation and de-encapsulation. NSX uses this VXLAN based hardware VTEPs, which are the tenants, to map it with software VTEPs running on ESX servers. So VXLAN encapsulation and de-encapsulation is performed at each endpoint. So the idea behind this hardware VTEP is to create an overlay network that connects virtual machines and physical servers. This makes them think that they are in the same network, even if they are on the different sides of the globe.
Okay.
So the solution here is you need to develop hardware VTEP capabilities on the physical switch that will be connected to your virtual network.
Okay, that makes sense. So before I move ahead, Misbah, what is the full form of VTEP? Can you tell our listeners that?
Sure. So VTEP is VXLAN tunnel endpoint.
Okay.
And so this tunnel endpoints are basically a physical hardware device that it could be a physical switch with VXLAN capabilities or some software application like OpenVSwitch, which could be capable of encapsulating packets with VXLAN headers. This VTEP basically maps physical ports and VLANs on those ports to logical networks, so that any physical device can participate in a given logical network, communicating with the virtual machines that are also connected to that logical network. So NSX hardware VTEP integration gives the owner of the application this ability to bridge their logical layer 2 network, that is NSX Logical Switch with VLANs. Apart from hardware VTEP, you have these software VTEPs running on each ESX host. So the number of ESX hosts that participate in the NSX, you will have those many number of software VTEPs available to establish tunnels between the hardware VTEP and software. Yeah.
Okay, makes sense. Okay, perfect. So Misbah, when it comes to NSX, how does this work? Why is there any specific configuration required on the NSX?
So let me cover what is the implementation on the NSX side. NSX controller basically implements database access protocol, OVSDB, Open vSwitch database, which is open source. This OVSDB is used for the purpose of configuring and monitoring Open vSwitch instances running on your physical hardware. This OVSDB protocol implementation by NSX is used to control your third-party VTEPs. This feature has made VMware hardware partners able to leverage the open source implementation of OVSDB protocol. Thus, implementing OVSDB on switch enable their switch to learn MAC addresses of physical servers, whereas one or more NSX controller on the NSX side collects the MAC addresses of virtual machines on ESX hosts. So you got marked that using the OVSDB schema, the components in the physical and the virtual networks exchange MAC addresses and other information. This enables components to learn and reach each other in the respective networks.
Correct.
So let me complete this overlay technology. This overlay technology enables VXLAN to VLAN translation.
Okay. So this is obviously L2, right? You said that we won't be talking about L3, but do you quickly want to tell us what more is required when it comes to this L3 integration?
Yeah, I covered mostly on layer 2, but on layer 3 also this hardware VTEP integration is quite possible. So when it comes to layer 3, you need to introduce this distributed logical router and NSX as services gateway. So those kind of configurations are required. Maybe I'll cover that in another podcast.
Okay.
Does that make sense?
That does, perfectly. Okay, so thanks for this detailed information, Ms. Ba. So to achieve all that you have mentioned above, how does NSX authenticate third-party integration then?
Yeah, third-party integration, NSX requires SSL certificates to be present on the third-party switches for third-party integration basically. They call these switches as hardware gateways. While adding hardware gateway on NSX GUI, NSX expects certificate that need to be present on the switch, and that should be cut pasted from the switch to NSX. So basically you are supposed to generate the certificates and its keys on the physical switch, and NSX expects and understand those keys, but these keys needs to be in RSA encrypted format.
Okay, that makes sense. Okay, well, thanks for your time today, Ms. Ba. It was great having you with us on the show.
Thank you so much. Thanks a lot. My pleasure.
So obviously Ms. Ba has mentioned that he will be tackling the L3 integration in another podcast, but if you have any feedback for us in the meanwhile, you may write to us at marketing@calsoftinc.com. That email address again is marketing@calsoftinc.com. Thank you and have a great day. Bye-bye.